Let's take a look at DNS in the Wireshark application and see what we got here. The first few things to notice here is that DNS, which is an application layer protocol, uses one of the two transport layer protocols, UDP and TCP. In this case, it uses UDP protocol on port 53. Right over here, we can see user datagram protocol, destination port 53. DNS is usually present as pairs in two rows. One is the query from the client to the DNS server, and the other one is the response from the DNS server to the client, where client is our computer. So you can see that one of these rows says standard query, and the other one says standard query response. So let's click on the DNS over here. What we notice is that this one says standard query and the other one says standard query response. Let's check out more details about DNS by clicking on the flags. For the DNS query packet, the first flag bit tells us that it is a query. The client is asking for the IP address of www.udacity.com, which is a type A address. Similarly, in the DNS query response packet, the first flag tells us that it is a response. And then we notice that the responding DNS server is not the authoritative domain server, which means that the upstream DNS will recursively request the authoritative domain on behalf of the client in order to get the IP address or the host name. Also in the fourth flag, we notice that it says recursion is desired, which means that the DNS server will recursively look up for the authoritative domain on behalf of the client. The responses give out the FQDN of the DNS server, its type, class, as well as the time to live, which is the time this information will stay in the cache of the server or the client in seconds. Let's see. So this is the query that we saw in the previous packet, and we see 3 answers in the current packet, 1, 2, and 3. Here what we see is the host name, the type, and the IP address, the time to live, the length of the data packet, and the address, the IP address, that is. So this was about the DNS protocol.